So we've got Faraday's law that's next up. A couple of things that you need to just remember from past science classes, maybe physics class or even Science 9, we talked a little bit about this, and that is a definition of current and voltage. And so the difference between current and voltage is really just quantity and pressure. Okay, so current is the quantity or the number of electrons that are flowing, and obviously the more electrons we have flowing past a particular point in a circuit, the more current we're going to have. For the voltage, it's really the pressure that's flowing or being applied on those electrons for them to flow. And so the more pressure that we have being put on those electrons, the more potential that they have to move quickly. It doesn't necessarily mean that they will move quickly, but they will have the potential to move more quickly if they've got a higher pressure. So in other words, a higher voltage. Now for Faraday's law, this is the formula that you need to know. And this is a formula that's not found in your data booklet, so it is a formula that you would need to have memorized. And it just reads that the moles of electrons is equal to the current times the time divided by a constant called Faraday's constant. And so here's just kind of a layout of the different parameters and variables that are found in this formula. You can see that moles of electrons is just measured in units of moles, or moles of electrons, usually written like this, M-O-L-E with a negative to denote electrons. Current is measured in amps. Time is measured in seconds, and that one you really have to pay attention to. I've noticed over the years lots of kids have made mistakes where a question will give them time in minutes or time in hours, and then they plug that number that's just given to them in the question right into the formula, and you won't get the right answer if you plug time in any other unit other than seconds. And so make sure that your time is in seconds when you're doing these problems. And then Faraday's constant is just a constant. It's found in your data booklet, but here it is on the board as well, 96,500 coulombs per mole of electrons. So those are the units. If I plug those units in over here into this formula, you can see how these things are arranged. And you might ask, well, okay, so how do the units cancel here? Because it doesn't really look like I'm left with just moles of electrons. And it turns out that if you take a look in your data booklet, you can see that 1 amp is equal to 1 coulomb per second. So in other words, if we just take these numbers away, like that, 1 amp is equal to a coulomb per second. So if I plug that in to this portion of this formula, now you can see how these numbers or these units will cancel out. And so you can see my seconds will cancel because I've got seconds on the top and the bottom. Coulombs will cancel because I've got coulombs on the top and the bottom. And so what I'm left with is just moles of electrons, which is on the bottom of the bottom, which means it's on the top. And so that just equals moles of electrons. So moles of electrons equals moles of electrons, and that's how that works. Okay, so quick little practice problem that's pretty basic. Just in terms of using this formula is you can just simply be asked, you know, what is the number of, or what is the mole of electrons that's required to have a current, or to have a current that's running at 5 amps for 2.5 hours. All right, and so you just use your formula for Faraday's law right here. You plug in the numbers that you have and solve for your unknown, which in this case is just moles of electrons. Now 2.5 hours is equal to 9,000 seconds, so I need to make sure I stick that into my formula like that in terms of seconds. And I plug all of that into my formula. Punch it into my calculator, and I end up with 0.466 moles of electrons as my answer. And that's the first problem. Pretty simple, pretty basic. I'll be back right away with a second problem that's a little bit more complicated and show you a couple other things that they include as they ask you to try and solve some things using this formula. So I'll be right back. Here's our next example that shows us a little bit about how Faraday's law is connected to electroplating. So a couple of things to recall from a few of our last lessons. First of all, electroplating occurs with an electrolytic cell. So remember, these are electrochemical cells that require a power source. And all the power source is either a battery or you're hooked up to the wall to some electrical circuit where you're providing electrons to that cell in order to push the electrons in the way that you want them to go. So obviously there's going to be a current. You're going to run that current for a particular amount of time, and you're supplying that power to the circuit in order to run. And these are just non-spontaneous reactions that we're forcing to go in a particular way. So if you take a look at this statement up here, all it says is that it wants you to figure out what mass of copper is going to be electroplated onto a particular substance. So we can electroplate or copper plate things, electroplating them with copper. We can electroplate chromium, which is, you've heard of probably things that have been chrome plated. So we can use a bunch of different metals, gold plating things. We can use a bunch of different metals to electroplate them onto other substances. And so copper is just one of those that is fairly common that you'll see. And I've underlined a couple of key phrases or words in this sentence. First of all, this question is asking us to calculate the mass of copper. And so I'll show you how this is to be done. Also, you'll notice that this is being deposited at the cathode. And if you remember from our previous lessons about electrochemical cells, the cathode is the electrode where the mass will increase. Remember that the anode is where oxidation occurs, and so the mass will decrease over time. The cathode will increase. And so this is where electroplating occurs, is at the cathode. As such, if you remember from our rules of electrochemical cells, at the cathode is where reduction occurs. And so because of that, you'll notice I've written a reduction half reaction for copper. And this is just the reduction half reaction that is out of your data booklet, where we've got copper solid, which is what we are electroplating, is just copper metal. And so this is the reduction half reaction for that in order for that to occur. Okay, so it gives us some numbers. It tells us the current was run at 9 amps and it was run for 50 minutes. So how are we supposed to figure this out? Well, anytime that you see a number where you have amps included in the question, either it's asking you to calculate how many amps or it gives you a number in amps, then that's going to require you to use Faraday's law. And so you can see I've got the formula written up here on the board where we calculate the moles of electrons using the amps and the time in seconds, 3,000 seconds, to calculate how many moles of electrons are present for this electroplating process that's going to occur. So I plug this into my calculator and I get 0.2798 moles of electrons. Now you'll notice I put the ... here because this goes back to our rules of stoichiometry and any other calculation that we've ever done, which is never round your answer until the very end when you're finally finished. So yes, this is a rounded answer on the board just for the sake of simplicity, but when you're doing these calculations, make sure that you're using the big long number that ends up being in your calculator, that irrational number, so that you can carry it on through into your other calculations. So once I've calculated how many moles of electrons I have, I can go to this reduction half reaction to do a little bit of stoichiometry to help me solve for this problem. So again, you'll notice that, okay, I've got the moles of electrons, which is essentially what was given to me in this format where they said, okay, here's the amps and here's how much time it was run for. They essentially are giving me how many electrons I have. So that's my given right here in this half reaction. And so I've written that underneath. That's how many moles of electrons I actually have. And my required is what I'm looking for, right? That's the mass of copper. And so I've got the mass with a question mark. And if you remember when we did our review of stoichiometry, you have to have a molar mass where you have a mass that's either required or given to you. And so in this case, we're asked to find the mass. So I need the molar mass of copper in order to figure that out. And then it's just some simple stoichiometry from here, really. We've got 0.2798 moles of electrons, And you can see all I'm doing here is the mole ratio. And all this really means is that if I had 2 moles of electrons, then that's going to give me 1 mole of copper for this process. And so I don't have 2 moles of electrons, I have 0.2 something something moles of electrons. And so how many moles of copper am I going to have? Well, I'm going to have half of that. So that's why you see this mole ratio written like this, just the required over the given. And you can see that my units cancel out. So my moles of electrons are gone. You can also see that the moles for the copper also cancel out as I use that with my molar mass of copper. And so the units that I have left over are grams of copper, and I can plug this into my calculator, and the answer that I end up with is 8.89 grams. And that's really it. This is what I would say is the other type of Faraday's law type of question that you'll see. And another type that is very similar to this is instead of giving you the current and the time, what they'll say is they'll say, hey, you electroplated 8.89 grams of copper, and we want you to calculate how much current is required in order for you to do that, if you ran the current for this much time. And so really it would just be kind of working backwards. You were given the mass, so you need to find the moles of copper, convert that into the moles of electrons, which then you can plug into this formula and solve for I. It would require a little bit of algebra to rearrange Faraday's law formula to solve for I, but you can do that. And then once you solve for I, you can plug the numbers in and calculate the current that's required. And so these are the 2 types of questions that you'll kind of see that are a little bit more complicated as it relates to this formula. One kind of working this way, asking how much is electroplated, usually in grams, or if they give you how much was electroplated, oftentimes they'll either ask you to calculate for the current, or sometimes they may even ask you to calculate how long it would take for you to run that current in order to electroplate that mass onto that substance. So hopefully this is helpful. You can hit up some of your practice questions, and we'll see you guys in the next video.